What's up, YouTube? Today we are solving the daily LeetCode challenge, question 452, minimum number of arrows to burst balloons. There are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points, where points I equals X start, comma X end, denotes a balloon whose horizontal diameter stretches between X start and X end. You do not know the exact Y coordinates of the balloons. Arrows can be shot up directly vertically in the positive Y direction from different points along the X axis. A balloon with the X start and X end is burst by an arrow shot at X if X start is less than or equal to X and less than equal to X end. There is no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons in its path. Given the array points, return the minimum number of arrows that must be shot to burst all balloons. Wow, that was a wordful. A mouthful. So the solution to this problem is to sort the balloons by their y-axis, and this will give us the furthest balloons out first, and we're doing this because there are the most balloons at the furthest out. So the furthest balloon always have the most balloons is why we sort the balloons by their y-axis, and then we shoot arrow at the first balloon Y. So we shoot an arrow at the first balloon's Y because our first balloon is the furthest out balloon, and at its y-axis is at the end of the furthest balloon. So this is the furthest we can go. So we shoot an arrow there, and then we have to pop or remove all balloons that intersect with arrow. And we will continue until balloons is empty. And then we just return how many arrows we shot. So this would take a O of n log n time complexity because of the sort function, and the space complexity is just all 1 because we sort the points in place. We don't use any extra memory. So let's code up our solution. Points equals, actually we sort the balloons by their XY axis. So we sort their y-axis first and then their x-axis second. So points equals sorted points key lambda k1 and k0. And we have to put this in brackets. So we sort the balloons, and then the furthest balloon always have the most balloons. So we shoot an arrow at the first balloon's y. Points so we have to shoot an arrow at the first balloon's y. So the first balloon's so our arrow is at, okay, so we're going to count the arrows, and our arrow is at the first balloon's Y, and then we pop so we'll pop all balloons that intersect with the arrow with a list comprehension. X star, which is X point X arrow point Y, like that. And return arrows. I believe that's it. There you go, ladies and gentlemen. O of n log n runtime complexity and O of 1 space complexity. See you in the next one. Oh, what the?